Hello there, Mr. Sutton here, bringing you this lesson on the probability of disjoint and overlapping events. In this one, we're going to take a look at probabilities of overlapping and mutually exclusive, aka disjoint events. And for real-life applications, we're going to determine chances of picking certain cards, marbles, chocolates, all of our favorite things in life. For the warm-up on this one, we've got another pause and reflect kind of question. The card's randomly picked from a standard deck. Billy claims the following two events have the same probability. Is he right or wrong, and why? So first event, card is a red card or a club. Second event, the card is a black card or a spade. Pause and reflect on this. So on the face of this, it looks like these are pretty similar. In one case, we haven't really dealt a lot with or statements, but in one case, we're saying the card could be either one type of color or one type of suit. And in the second case, we've got a color and a suit. So theoretically, these should come out to the same thing. However, there is one key difference. In the first case, are there any red cards that are also clubs? Well, no, club is a black color. It's one of the black suits. So these two events here, red card or club, you could say that those are mutually exclusive. You can't be in both of these, well, I hate to say it, but clubs at the same time. This one down here now, black card or spade, are there some black cards that are also spades? Well, yes, there are, because spades are one of the two black suits. So whatever we count for this condition over here, we're also going to be counting some of the cards that fall in this condition. So I'm not sure these are both going to give us the same probability when all is said and done. Those two examples in the warm-up are an illustration of the difference between what's called overlapping and disjoint events. With disjoint or mutually exclusive events, these are events that have no outcomes in common. So just to get a nice little Venn diagram to show you this. So let's say we have one event like, has Mr. Sutton for Integrated Math 3 Honors? And let's say we have another event like, has Miss Quinn for Integrated Math 3 Honors? Well, you can't be in both mine and Miss Quinn's class at the same time. So if we want to find the probability that a student's in one of our classes, since we don't have any students in common, we can just basically add our probabilities together. So if you want a formula for this, you could say probability of A or B equals probability of A plus probability of B. Just add them together and be done with it. Now this is a little bit different than if you have what is called overlapping events. These are events that have outcomes in common. So here's a Venn diagram of that situation. So let's say, for example, one event is, has Mr. Sutton for math, and another event is, has Miss Capasso for humanities. Well, there are some students I have for math that maybe don't have Miss Capasso, and maybe she has some students that don't have me for math. But we do have some students who have both of us. So if you're trying to find the probability that a student has me or Miss Capasso, yeah, you could add all of my students and all of her students together, but then you're double counting the students that we have in common. So to resolve this situation, we are going to add those probabilities, but we're also going to subtract the overlap so that we're not counting it twice. If we want a formula for this, we could just say P of A or B equals P of A plus P of B minus P of A and B. So basically, probability of A plus the probability of B minus the probability that you meet both conditions at the same time. Given what we've just talked about, see if you can reason out what to do in this situation. So we have a card randomly selected from a deck of 52. We want the probability it is a 10 or a face card. Pause the video and see where you can get with this one. All right, so can you be a 10 and a face card at the same time? Whenever you're dealing with an or statement, that's the first question is, can I be part of both groups? And the answer here is definitely no. Face cards, well, have faces on them. 10 does not have a face. You can't be a 10 and a face card. So we're just going to add the probabilities. We don't have to worry about subtracting any overlapping parts of the groups here. So we're just going to do basically P of A plus P of B. So to find the probability of being a 10 or a face card, we've got the probability of being a 10, which there's 4 10s out of 52 cards in the deck, so that's 4 out of 52, plus the probability of being a face card. There's 3 face cards per suit and 4 suits, so that's 12 altogether out of 52. And we just have to add these together. Again, there's no overlap, so this is 16 out of 52, which we can then reduce to 4 out of 13. So one little tip on this one, you might have noticed that It's nice to have common denominators when you're adding fractions. For this reason, I very heavily recommend, since you're adding these fractions, don't reduce right away. That'll make it easier to add them. You can just reduce after you've got the final probability. Here's another example for you to try out. We randomly select another card from a deck of 52. We want the probability it is a face card or a spade. Pause the video, try it out. Okay, so is it possible to be a face card and a spade? Definitely is. Hey, here's the Queen of Spades, a face card that is also a spade. So since it is possible to be a face card that's a spade, we have to subtract the overlapping members of that group. So we're doing this formula down here instead. P of A plus B of B minus P of A and B, minus probability that you are a spade and a face card. So let's get these individual probabilities. Probability of being a face card, that's still 12 out of 52. Probability of being a spade, well, that's one of your 4 suits, so that's 13 out of 52 that we're adding there. And now, how about the overlapping members? Which spades are also face cards? Well, we've got the Queen of Spades, the Jack of Spades, and the King of Spades. So that's 3 overlapping members that are parts of both of these groups that we have to now subtract so that we're only counting them for one of these groups. So adding all this up, we've got 25 minus 3 is 22 over 52, which we can reduce to 11 over 26. Try this next one out, and this one they want us to determine if it's overlapping or disjoint events, then find the probability. So bag contains 5 red marbles, 3 blues, and 3 yellows. Randomly picking a marble, is it red or blue? Okay, let's see how this one went. So since you can't be red and blue at the same time, I mean, at least the way they phrased it, we have 5 reds, 3 blues, and 3 yellows. They didn't say we have any weird, like, combination marbles. These are going to be disjoint events. You're red or blue. You can't be both in this situation. So what does that mean? Well, that means we're just going to add the probabilities together without having to subtract anything. So we have the probability of being a red marble. That's 5 out of, let's see, altogether 11. Probability of being a blue marble, which was 3 out of 11. So we're going to add 5 elevenths and 3 elevenths together. And then that's just going to add up to 8 elevenths. We're going to do one more problem, and we're going to end on a sweet note here, talking about chocolate. So we have a box of chocolates with 6 milk chocolates, 4 dark chocolates, and we have 3 milk chocolates that have peanuts and 1 dark chocolate that has peanuts. You randomly select and eat a chocolate. Hope you're not allergic to peanuts. What's the probability it is a dark chocolate or has no peanuts inside? So figure out if this is overlapping or disjoint. Find the probability, pause the video, give it a shot. All right, so first off, is it overlapping or disjoint? Well, we're asking the question, are there dark chocolates that don't have peanuts inside? And there definitely are. They talked about one of the dark chocolates has peanuts, so there's a few dark chocolates that don't. This means this is an overlapping situation, and we have to make sure that we subtract any members of the overlapping groups. So let's go ahead and find those individual probabilities. If we're asking about dark chocolate or no peanuts, what's the probability that we have a dark chocolate? We had 6 milk chocolates and 4 dark chocolates. So that means 4 out of 10 were dark chocolates. That's our probability of dark chocolate here. And now we have to do the probability of no peanuts. Well, let's add up how many had peanuts. We had 3 milk chocolates with peanuts, 1 dark chocolate with peanuts. That's 4 altogether. So that means 6 out of 10 did not have peanuts in them. And now we're talking about dark chocolates that have no peanuts inside. Well, again, if one of the dark chocolates had peanuts, 3 did not. So that is, let's see, 3 out of 10 overall that are dark chocolate with no peanuts. So subtracting that from our first 2 here, we've got 10 over 10 minus 3 over 10. That's 7/10. So that's it. There is nothing left to cover in this one. Until next time, Mr. Sutton signing off.